All right. Um, lucky day. Oh, green. Okay. Questions? Questions?
16D.
16D. What? Okay, let me.
I second his question.
Yeah.
Okay. Let me. What was the problem? I don't remember.
It was the
Just 16D.
I mean
Just
it was the scanner one.
You had to parse out a couple words and
All right.
do that.
Yes. So that was the one where we had an input that said, what was it? The chancellor's salary, and then like what was it? 1998, and 2011, where he made whatever 495,000 or whatever the poor guy gets to make ends meet. Now you have to be able to read these things in. How do you read in a line of input? So we need a scanner. And you just need to look up how to construct a scanner. Oh, I see. Actually, didn't I make a scanner for you?
Yeah, you provided the scanner.
So I'm giving you a scanner, right? There's several ways of making a scanner. You can make it so that it's attached to the keyboard, but I figured with this kind of thing, when you need to can test these more complicated things over and over, I hate it if I have to retype this text 20 times. And so now I made it so that you can just read it from the file. That when you run the program, it pops up a file dialog, and then you can just open the file in the file dialog, saving you the trouble. And I'll show you later a way where you can do it even more easily, but it requires more technical expertise. So, so we have the scanner. How do I read the first line?
You gave that to us.
Okay, tell me.
And next line.
So I say string. It's next line. Okay. Now, how do I read the 1998, the number?
Is it like integer, like blank equals next integer?
What should I call it?
Year one.
Year one, excellent. Year one equals in dot next int. How do I read this value here?
The next 200,000.
Yeah, the 200,000.
Double salary one.
Yeah. Well, it's probably not a good idea to call it salary one, because here it was the salary, but in some of the other examples it was like the consumer price index. It could be any old value.
Value one.
Exactly. Next what?
Next double.
Yes. How do you read these two?
Create a string like amount one, string amount two.
No, you don't want to read them as strings. You could read them as strings, but then it would be hard to do arithmetic later because you're asked to like compute percentage increases.
Oh, okay. So like int int amount 1, int amount 2.
Well, we already read them as year 1, we already read this one as year 1, this one is amount 1, so what would this one be?
2, right?
Year 2.
Just year 2 and then amount 2.
And you would do them in the same way. And then for a technical reason, now we want to be able to read the next line, which might be, let's say, what was the last line, end, E-N-D?
Yeah.
Okay, so now we want to read the next line, and for a technical reason, there is a new line character that's still stuck here. The what do you call it, the amount 2, amount 2 reads up to here, and then I'm in the loop. I want to go back to the top of the loop and read next line again. But if I'm here and I read next line, then I get a blank line. Did everyone get that? See, at this point here, I'm going to do some processing, and then I'm going to go back to here, because I have multiple packages of this information. So I have to read the first group, then I have to read the second group, and so on. And so when I go back up to the loop and I call next line again, it's not going to work like this because I have consumed this number, but I have not yet consumed the end of line here. If I were to call next line, then it would say, oh, the next line is nothing, and I would get a blank line. And this is always the case, and I protect myself against that by putting in another call, sorry, it's more crammed in here, to in next line. And I've given you that because it's kind of a tricky and unusual aspect. This call to next line here consumes this thing. Now I'm going back into the loop, and I can now read, when I call this next line here, then it reads the next line that I actually want. So that's the basic structure, and I'll have to start a new thing here. So I have while, then I have all of these reads, a bunch of reads of next instructions, the ones that you've seen on the previous writing. And now I'm going to process my data. So I'll have to figure out what is the percentage increase, what is the number of years that have elapsed. And then I print out something. And then I'll move on to read the next record. The next description, the next year 1, the next value 1, the next year 2, the next value 2. And then I'll go on to read the third one. And the fourth one. When do I stop? What does the problem say? When do you stop?
When it sees end.
When it sees the string end. Okay, so where do I know when the end has been seen? This is a problem that is typical for these input loops. You read some amount of stuff because you're processing data. So over here, I was reading the description, right? String. And now at this point here, it may happen that the description is end. And then what should I do? What should I do? If here, should I go on and call next again to read the year? I need to get the hell out of here, right? How do I get out of here? I'm in the middle of the loop.
Right.
A break?
Ah, okay. So there is, if you may have seen that from another programming language, or if you've read the advanced topic in the book. So there is a command whose purpose is to get out of the middle of a loop, but it's frowned upon. It's not something that you should be using. Instead, it's actually quite easy. What you do is over here, you now shoehorn in that says, if something has happened, then you keep on going, and otherwise, you say done equals true, and in the loop condition, you say while not done. Did I give you this outline?
Yeah. No, you didn't. You want to use it while.
I wanted you to find that in the book, I guess.
Sure.
Or I wanted you to realize that you have this problem. So, so this is kind of a basic outline that works like for any loop where the exit condition is somewhere in the middle. And lots of loops are like that, because lots of loops, you do some amount of work, and only halfway through that work, you know that I actually need to exit. Whenever you have one of those kinds of loops, the easy way of controlling it is with a Boolean variable. And always call that Boolean variable done, because everyone likes to be done. And so then the loop says, while not done, you keep on going. And as soon as you found that you are done, because whatever it is that you were trying to achieve has been achieved, then you set done to true, and that's the end of it. You could also invert this. You could have it, or the other way around. Some people prefer to arrange it like that. You could say, so we have a string description. So we now say if the description, equals end, maybe this is a little nicer to read, because then it becomes very clear. Now you found your termination, you said done equal to true, and otherwise you do all the regular work. Read more numbers, process the numbers, print out the results. More questions about this? So this is a very common structure that you find just about any time you process input. And again, the reason is that when you process input, you normally know that you come to the end of the input because there's some special marker that marks the end of the input. Does anyone remember from the book what the name of the special marker is? Like in this case, the word end. It's called a sentinel value, because it's a special marker to indicate the end of input. It's different from regular input. So there's an example program in the book that I suggested you read where it reads in a bunch of numbers until you hit Q or some such thing. And when you look at the loop in there, it has the exact same structure. So, what I think you should really do is when you're at a point where you say, I don't have an idea how to read this, or I don't know where to start something, you should put a question on desire to learn. I don't think there was any desire to learn question on 14D. Was there any? Did anyone ask?
What?
Did anyone no, a 16D, right? Did anyone ask a question about it?
Yeah.
And I did. You asked and I didn't give a good answer?
I don't remember the answer.
Okay, I'll look at it.
Check it out.
Yeah, so, but lots of you should put questions on there.
Give an answer.
I gave an answer, All right, lots of you should put these kinds of questions so that I know what it is that you have trouble with. Yeah?
When I run the program,
Yeah.
it asks us to open a file. What file are we supposed to select?
You need to make a file. You need to make a file called whatever, input.txt. You need to put it in a place where you can later find it. And you need to copy and paste those 3 or 4, 6, 7, 8, 10 lines from the sample into there. Or maybe you need to make your own sample if you don't like my sample. And so that's we're going to be doing this kind of file processing quite a bit because that's a pretty realistic thing that people do with programming all the time. Like right now, I'm doing graduate admissions, and I have several hundred applicants. So I have this program that goes through everyone's transcripts and copies out which university they were from, what GPA they had, and stuff. And so my program opens 200 files, reads them line by line, gets to the right point, and then copies that out so that I can copy it into my spreadsheet easily. And I wrote that in good old Java, using exactly this kind of techniques that we're doing here for a single file. So we'll see more examples like this. Every time you make the file, you put it somewhere, and then you read it. Just in this case with the file dialog.
And it's usually just like a .text file, right?
Yes, it's yes. So we always want to use the text files, and because it's easy to read a text file. If you wanted to read like a spreadsheet or a Microsoft Word file, then they have all sorts of crazy symbols in there for formatting that would be very difficult to read. Whereas plain text is just this. You read a line of text, you have it in a string, you process the string. And in fact, at one point I said, when you guys like submit lab reports and stuff, you should just do it as plain text, and that's because plain text is just easy to develop. The other thing that's still pretty easy to deal with is, and this may happen to one of you, like if you have an internship or something where you need to deal with spreadsheets. It often happens that some manager has some spreadsheet and it needs more processing than poor old Excel can do. And then when they can export it into comma-separated values, and then you can write a Java program that reads it in and processes them. So these comma-separated values that you have in the other assignment are just something that really does happen in real life, where you have some string, you have a comma, you have a string, you have a comma, and then you need to write a little program that fills these apart and gets you to these individual strings. So it's a very common and very realistic thing. And I'm going to, right now when you look at that CSV class, it sounds like a total overkill, right? I'm adding these things with the commas, and also that I can give you an assignment to count commas later. But I'm going to be building on this and add some extra layers of complexity on it because it's a great way of practicing loops. But it's taken from a realistic context. So how did I didn't ask you what you needed to complete in this one here for the draft, but this one is actually pretty easy. How do you do it?
What is this?
16B, see the CSV one, not the reverse one. The reverse one is tricky. The CSV one.
Oh.
It's also 16B.
So my question is, how do you compute you were supposed to implement what method? The size method.
Count or
Well, yeah, I foolishly called it count at one point, but I really meant size. And with size, I mean the number of items in this container.
Yeah.
So make sure to rename it to size for the final one, if you still call it count.
Is it okay if we just change it tester and just
No, change them both to size for the final one.
size?
Yes, because the grader may use a different tester. So change it to size. So how do you evaluate the size? Because all you have is the string with the commas. Remember, you were not allowed to add any instance variables. Otherwise, it would be an easy business. You could add an instance variable and increment it in every call to add, but you were not allowed to do that. The rubric, in fact, will say anyone who added an instance variable will get 0 points for this problem. So double check to make sure that you didn't do that. I want you to practice loops. So how do you figure this out? You are not allowed to add any instance variables.
So what would that look like? It would be just count how many times you add a string or add
Okay, the thing that you're not allowed to do
Right.
is you're not allowed to add an integer count and that you would increment in every call to add.
every call to add. Oh, okay.
Yeah, that would work,
Right.
but it's not what I want you to do. I want you to just look at this string.
So would you want us to count the commas and then
Yes,
add one?
I want you to count the commas
Then add one.
and then add one, because there's one more item than there are commas, right? How do you count the commas?
Because
A substring
it's counting the
of
items, not the commas. So you start with one.
Okay, which related problem have you already solved that's just like counting the commas? It's just like counting the vowels, right? It's exactly the same idea as counting the vowels. You go through the string, a character at a time, you look at each character and you say, are you or are you not a comma? Just like we asked before, are you or are you not a vowel? And that's exactly the same logic. All right. Keep those questions coming. So now we've covered everything that I wanted to cover for the lecture in the guise of the homework, and we might as well move on to the second part of the lab. So I want you to finish up that lab, what is it, 8A, the one that we kind of got half done last time. And so I want you to come up with the pseudocode for that vowel group counting algorithm. So I want to see pseudocode. I want to see that pseudocode executed with that little diagram. So we have a pseudocode here that says while to do this, do that, do that, and I want to have this diagram where we have the variables, whatever variables you can come up with, and you cross things out and write other things, whatever it is that your algorithm does. I want to see it simulated on the sheet of paper. So I'll be making the rounds to see that that's going to materialize.